In this video, we are going to continue practicing the graphing of tangent functions, and these next couple of problems are going to involve a different b value, so the period is going to change. So quickly, let's remember the basic look of the tangent function. Focusing on the yellow on the right, this is one period of the tangent function, similar to the sine function, which begins and ends its period on the midline. Tangent also begins and ends on the midline. All right, this is one period over here to the right. Now, something new with tangent is that there's a vertical asymptote halfway through the period. Notice that tangent is always rising, so it's increasing towards the asymptote, and then it begins again and is increasing back to the midline. For tangent, we usually draw two periods, all right, as I've shown here, and the reason for that is to be consistent. When we draw one period of the sine function, for example, this is 2 pi, all right, because the sine function has a period of 2 pi. When we draw one period of the cosine function, we are drawing 2 pi. Unless there's some sort of a change in the equation. But one period of the tangent function is only half that. One period of the tangent function is only pi. So in order to get 2 pi worth of the tangent function, you have to draw two periods of it. So that's why we do that. So looking at problem number 3, the a value is 1. So that'll come up later. But right here we have a b value of 2. That's going to affect the period, all right, because the period is always the regular period divided by the b value. And for tangent, the normal period is pi. All right, so the new period will be pi divided by 2. And that's it. All right, there's nothing else for me to do. So the period is going to be simply pi over 2. Alright, I like to do my x-intercepts after I look at the graph, same with the vertical asymptote equations, but the phase shift, there's nothing being added or subtracted inside here. There's no h value, so there is no phase shift. So I'm just going to go ahead and put none. Now, when we begin the graph, when there's, first of all, you should just write I like to graph by just making a number line and marking it evenly all the way across. Just start with that. Now, for the tangent function, when there's no phase shift, it starts at 0. So I'm just going to go ahead and mark 0 right now. So my tangent function is going to begin and end on the midline. Okay, so the tangent function will begin here. Every one of these marks represents 1/4 of the period. So if I just count my way over 1, 2, 3, 4, then I know that the period should end right there. Okay, now the period is pi over 2. Alright, so that means this should have a value of pi over 2. If I go half of that, that's going to be pi over 4. If I go half of that again, that's going to be pi over 8. And this should be 3 of these, so this will be 3 pi over 8. Alright, so these are the values that will give me one period of the tangent function. Now, right in the middle, there should be a vertical asymptote, which I will show as a dotted line. Alright, let's go ahead and throw the y-axis in here. And the y-axis is definitely going to be right at 0. So I'm just going to go ahead and draw myself a y-axis right here at 0. Alright, so that'll be my y-axis. Now the a value is 1, so I'm going to go ahead and mark that positive and negative on the y-axis right now. So right about here, I'll just go ahead and put a 1 and a -1. And now I'm going to do the graph. So the tangent function is going to start at the midline, and it's going to always be rising. So it's going to rise from here as it approaches the asymptote. Halfway over, it should be at this a value, so it should go through that point right there. Okay, and then it will pick up from down below, and as it rises toward the midline, I'm going to be careful to make sure that at halfway over, it should be at the a value again, the negative version. So it's going to rise like this. Okay, so there's one period of the tangent function. Now I'm just going to do the same thing to the left. So to the left, I've got negative pi over 8 and negative pi over 4 and negative 3 pi over 8 and negative pi over 2. Alright, so this is where the left period should begin. And again, right in the middle, there should be a vertical asymptote. So I'm just going to go ahead and put a vertical asymptote in right here in the middle of the period. Alright, so there's my vertical asymptote. Alright, and tangent function always rising, so I'm going to rise toward the asymptote, making sure that halfway to the asymptote I'm at this a value of 1. And then it picks up from down below, but I'm going to make sure that halfway to the midline I'm going to be at this negative a value. Alright, and this is what two periods of the tangent function should look like. Okay, now as far as x-intercepts, the x-intercept only happens once every period. So I'm going to just pick my first positive x-intercept, which is pi over 2. And I'm going to start with that. Alright, so since it occurs every period, then I'm going to add multiples of the period. So in this case, the period is pi over 2. So I'm going to say n pi over 2, where n is an integer. Okay, similarly with the vertical asymptotes. The vertical asymptotes only happen once every period. So I'm going to start with one vertical asymptote. I usually just pick the first positive one, which is at pi over 4. So vertical asymptotes are always x equals. So x equals pi over 4. And then I'm going to add multiples of the period. So again, I'm going to add n pi over 2. All right, notice I'm not just putting n pi, I'm doing n pi over 2 because for this problem the period is pi over 2. And again, I'm going to indicate that n is an integer. So that will do it for problem number 3. Alright, but let's slide right into problem number 4. Okay. Again, the a value is 1, but we have this b value, which is 1/4. That's going to affect the period. So the period is the regular period divided by the b value. So the normal period for tangent is pi. So that's why I'm going to do pi over 1/4. But the way you divide by a fraction is you multiply by the reciprocal. So the period is going to equal 4 pi. Alright, because I'm multiplying by 4, multiplying by the reciprocal. So the period is 4 pi. Now there is no phase shift because nothing is being added or subtracted inside the parentheses right here. So I'm going to put none for the phase shift, and I will come back and talk about the x-intercepts and vertical asymptotes after I finish graphing. Alright, because there is no phase shift, then I can know that the tangent function will start at 0. So I'm going to just put 0 right in the middle of my number line. You should make a number line like this. And know that tangent will start at 0. And each one of these marks is going to represent 1/4 of the period. So if I just go over 4 spaces, 1, 2, 3, 4, then this should be the end of the period. Now, we already said that the period is 4 pi, so that means that this must be 4 pi, which means that this must be 2 pi, which means that this must be pi, and this must be 3 pi. We know that for the tangent function, there is a vertical asymptote right in the middle of the period. So I'm just going to go ahead and draw a vertical asymptote right in the middle of this period. And a vertical asymptote should always be shown as a dotted line so it doesn't look like the y-axis. Okay, speaking of the y-axis, now would be a good time to draw that. Y-axis is always going to be at 0, so I'm going to draw the y-axis always at 0. Nailed it. Okay, so there you go. So now it's time to draw this graph. So the tangent function starts at the midline, and then it's going to rise toward the asymptote. Now the a value is 1. So I need to mark that on the y-axis for sure, because that's going to help me with the graph. So I'll put the a value here. So we have an a value of 1, and then also at -1. That comes into play as I graph because as I'm rising towards the asymptote, halfway over it should be at the a value. So it should be rising, but it should pass through this point as I go. Alright, similarly, I'm going to pick up from below and rise toward the midline again, but halfway over, again, I should be at the a value, so it should pass through this point right here on its way to here. Alright, so that is what one period of the tangent function should look like. Okay, now I'm going to do the same thing going over to the left. So if this is 0, I'm just going to have a negative pi, and then negative 2 pi, and negative 3 pi, and guess what? Negative 4 pi. Okay, so this is where the period should end or begin for the left side. Alright, the left period that I'm about to draw should begin at negative 4 pi. Again, right in the middle, I should have a vertical asymptote. So I'm going to draw one of those as a dotted line halfway through the period. Alright, my computer's being really slow all of a sudden. So great. Now I should be able to draw it. So I'm going to, tangent function always rising. So I'm going to rise toward this asymptote, making sure that halfway over I am at the a value of 1. And I pick up from down below, rising towards the midline, but making sure that halfway over I'm at the negative a value of -1. Alright, so there you go, 2 periods of the tangent function. Alright, now how about those x-intercepts? Let's talk about those. The x-intercepts are only occurring once every period, at the beginning, at the end, once per period. So I'm just going to pick my first x-intercept over here at the right, which is at 4 pi. Okay, so we have an x-intercept at 4 pi. And then, to get the repeated further x-intercepts, I will add multiples of the period. So I will add 4 pi n. Or, you know, I was debating where to put the n in this. Should I put n 4 pi or 4 pi n? I don't think it really matters. For some reason I feel like putting 4 pi n this time. Okay, where n is an integer. Alright, meaning it could be a positive or negative. And I'll do the same thing with the vertical asymptotes. So I have a vertical asymptote here at 2 pi, for example. So I'll start with that one, my first positive one. But then it will occur again every time I go a full period. So I'm going to add multiples of the period. So I'm going to add again 4 pi n. And again, this n is an integer. So that is going to do it for problem number 4. Okay, and I think I will stop this video here.